You ever look at a forest or a pond and just wonder, how does it all work? How do these complex systems bounce back from changes and just kind of stay stable over time? Well, it's not magic, right? There's this incredible biological principle at play. And that's what we're going to break down today. Let's get into it.
So yeah, it all really boils down to this one big question. I mean, with all this insane complexity, how does nature manage to keep itself in balance? You'd think it would just be chaos. But nope, most of the time, it's this beautifully tuned system.
Okay, so the best way to get your head around this is to think about something you probably have in your own home, a thermostat. You know how it works, right? It gets too hot, the AC kicks on. A little chilly, the heat fires up. The whole point is to keep the temperature stable. Well, an ecosystem has its own version of a thermostat, and its job is exactly the same. Maintain stable conditions so life can flourish.
Now, this ecosystem thermostat has a proper scientific name, and that's homeostasis. It's basically an ecosystem's built-in ability to regulate itself. It's this natural tendency to adjust and tweak things to stay in a state of stable equilibrium, just like your thermostat keeps things stable at home.
All right, so how does this whole balancing act actually happen? What's the secret sauce? Well, it all comes down to this really powerful mechanism that's always working in the background. It's a process called negative feedback. And this is absolutely key. Negative feedback is what creates stability. Now, don't let the word negative throw you off. It doesn't mean it's a bad thing. Think of it more like negating a change or counteracting it. Whenever something in the system starts to drift too far one way, this mechanism kicks in to pull it right back to the middle. This slide gives us a perfect real-world example of how this works. Let's picture a pond. Say the population of these little critters called zooplankton suddenly explodes. They're having a great time, right? Well, they start munching through their food source, the phytoplankton. But what happens next? They eat so much that there's a food shortage, which, you guessed it, causes the zooplankton population to crash. And now, with fewer predators around, the phytoplankton can recover. See? It's a beautiful, self-correcting loop. But what happens when a change is just too big? I mean, this self-regulation is an amazing system, but it's not invincible. Every single ecosystem has a tipping point. Scientists have a name for this comfort zone. They call it the homeostatic plateau. You can think of it as the range of stress an ecosystem can actually handle and still bounce back from. As long as the disturbances are within this range, it can keep its balance. But if you push it too far, that's when the system starts to break down. And this right here is probably the most important thing to remember about homeostasis. An ecosystem's ability to fix itself is not unlimited. There is a breaking point, a line in the sand, and once that line is crossed, the entire game changes. This visual just nails the concept perfectly. Look, under normal stress levels, the system's stability is high. It can take the hits. But when that stress becomes extreme, when it gets pushed way beyond that homeostatic plateau, the system's stability just collapses. The balancing act is over. So, if negative feedback fails, what takes its place? Well, that's when we enter a really dangerous downward spiral, and it's driven by the exact opposite force, positive feedback. Yeah, when an ecosystem gets pushed past its limit, positive feedback grabs the controls. And unlike negative feedback, which tries to fix things, positive feedback accelerates the change. It takes one small problem and just blows it up, pushing the system further and further away from any kind of balance. This table lays it all out so clearly. On one side, you've got negative feedback. Let's call it the balancer. Its job? Counteract change. The result? Stability. And on the other side, positive feedback, the unraveler. Its job is to accelerate change. And the result is, well, collapse. They're total opposites. The carbon cycle is such a great example of this. A little bit of extra CO2 can actually help plants grow. That's a balancing negative feedback thing. But if those CO2 levels get way too high, they shove the system right past its homeostatic plateau. And that's when you trigger these really harmful positive feedback loops, things that accelerate global warming, which in turn messes up the ecosystem's ability to handle carbon in the first place. It becomes this vicious downward spiral of degradation. So, all of this leads us to the final, and let's be honest, the most critical piece of this puzzle. What's the number one cause of the kind of extreme stress that pushes ecosystems past their breaking points today? The science on this is pretty clear. The source material really doesn't mince words here. It says humans are considered the greatest source of disturbance to ecosystems. Wow. Our activities are often that extreme stress that just completely overwhelms nature's ability to regulate itself. We're the ones pushing it from that stable world of negative feedback into the chaotic spiral of positive feedback.
So that really leaves us with one last massive thought to chew on. We understand how the balance works, and we understand how it collapses. And we know that we are the biggest source of the disturbance. So the real question becomes, knowing all of this, how do we change? How can we go from being a destabilizing force to a balancing one?